Hi everyone, it's Orkan. Today we have a problem when we are given a binary tree. So for example, in this case, we are given a binary tree with the root 3 and with the nodes 2, 3 and so on. And what each node represents here, each node in this binary tree represent the amount of money in the house. So each node is a house and the amount of money in that house. So for example, the root node has amount of money 3, the left child has amount of money 2, and the 3, and so on. So what we need to do is we need to find the maximum amount of money that robber can get robbing all of these houses. But the robber cannot rob houses that are adjacent. So for example, in this case, let's say that if robber robs the house 3, robber cannot rob the houses 2 and 3 because they are adjacent. Robber only can rob houses 3, in this case 3 and 1. So how we are going to solve this problem? We are going to solve this problem using the DFS approach. So what we are doing is, if we are in this case, right? So let's say this scenario. So starting from the root, if we are starting from the root, so what we do is we are recursively calling and getting the maximum value. We are getting the values for the left and for the right. We are getting two values. The first one is that when we are robbing, right? For the robbing, so let's say that which means that we are including this value, and another one is that we are not including this value, not rob, right? Not rob. So we are going to return for each node. We are going to return whether we are robbing, which means that including that node or not including that node. So we are recursively calling for the left child and the right child. And now what we do, we are for our root node again, right? Let's take our root node. If we are including 3 here, which means that we cannot take these values, right? We cannot rob left and right. So for that, we are including 1. So we are returning for each case, we are returning array with the size of 2. The first one represents the state when it's not robbed, so which means that we are not it's robbed, which means that we are including that value. And the second one, when it's not robbed, which means that it does not include that value. So it does not include the node 2 in this case, right? So and since we are for the rob, we are including the root value 3 here. We cannot include 2 and 3. That's why we are taking left and right. We are taking 1, which means that we are not taking this value. If we are not taking root node, right? If we are not taking root node, so which means that we can rob 2, we can take the 2 and the 3, right? Nodes 2 and 3. So for that, we are taking the maximum if we include the node 2, or if we do not include that. The same way we are doing for the node 3, right? For the right child. So we are taking the maximum if we are including that node, or we are not including that node, and we are doing that recursively. At the end, we are taking again the max value of the if we are taking the root node, or if we are not taking the root node here, and we are returning the max value.